In this video, we're going to learn how to find multiple missing side lengths and angles in one right triangle. So essentially, this is going to be what might be separate problems on other quizzes or assessments, and we'll put it all into one diagram. The first thing you should do whenever you approach one of these problems is identify what you are missing or what you need to find. And in this case, this triangle, I'm missing these two angles and this one side. So I'm going to go ahead and write that down as far as what I need to find. So I need to find two angles and one side. So I'm going to go ahead and check these off my list as I find them so to keep track of my progress throughout the problem. Pythagorean theorem, a squared plus b squared equals c squared, has three side lengths. In order for you to use the equation to solve for a third side length, you need to have two given side lengths. So if you have two given to you, you can use the equation to find a third. If you don't have two given to you, you can't use the equation at all. In this case, I have 5 as the hypotenuse and 4 is one of my legs, and I'm missing the other leg. So since I am given two of the three side lengths, I'm allowed to use this equation. So I'm going to go ahead and start by plugging in 4 and 5 in for B and C and make X my A. So A turns into X, B turns into 4, and C turns into 5. So to solve, square the numbers you know. So 4 squared is going to be 16, 5 squared is going to be 25. We're going to subtract 16 from both sides. X squared is going to be 9, which then makes X, after you square root it, 3. So since we found the one side length in our list here, I can kind of like cross this off as I've done it, and I can move on to the two angles. These two angles, this is the Greek letter theta, and this is the Greek letter phi. I have two angles to find. That means I need two equations to solve. And we're going to use trig for both of those. Alright? I'm going to start with theta. I want to find theta, so I'm going to mark my side lengths in accordance to what theta is. So 5 is going to be hypotenuse, regardless of what angle I'm talking about. It's always the hypotenuse. Here, X is going to be my opposite for theta, and then 4 is going to be my adjacent for theta. Now why I put the little theta there is that because while it's adjacent for theta, 4 is actually going to be opposite for phi. So when you change angles, you change labels. That's why I put the description there below opposite and adjacent. So we already know what X is, the approximate, or actually the exact answer, 3. So you can use that as part of the trig equation. I'm going to use 4 and 5 though, adjacent and hypotenuse, which in SOHCAHTOA is going to be cosine. So it's going to be cosine of theta is equal to adjacent over hypotenuse, so 4 over 5. Now if I'm solving for an angle, I need to get rid of the cosine by doing inverse cosine to both sides. And the inverse cosine and the cosine cancel each other out, or they undo each other. So you're left with theta is approximately, and here's where you type in second cosine 4 over 5. When you do that, you get theta is approximately 36.87 degrees. I'm going to round that. Alright, so we have found one angle, but remember that we need to find both angles, these two angles here. We wrote down there for ourselves. So section off another piece here of the workspace. We're now going to find phi. Now according to phi, 4 is actually going to be your opposite. I'm going to label that opposite phi, and then X is going to be your adjacent for phi. So in this case, I'm still going to use 4/5, but now it is sine. sine of phi is equal to 4 over 5. And it's sine because this is now opposite over hypotenuse in SOHCAHTOA at S in front of the OH is sine. Do inverse sine in order to cancel out the sine. So phi will be by itself on the left side. If you do inverse sine to both sides. So phi is going to be approximately second sine of 4/5, 53.13 degrees. Now I've found my two angles, I can cross that off my list. Let's try and make sense of the problem. These two angles right here. We didn't know these in the beginning, but we knew that this plus the 90 add up to 180 degrees. So our answers, two angles, should add up to, with 90, 180. Or if you were to subtract 90 from 180, the leftover would be 90. So these two should add up to 180. So, sorry, should add up to 90. So if you type in 36.87 and then you add that to 53.13, you should get 90 or very, very close to it. And it turns out we actually do get that 90 degrees where we're looking for. So these answers do actually make sense. So since we found our two angles on our one side, we are done with the problem entirely. Let's look at a problem where instead of giving you two side lengths, they only give you one, and they give you two of the angles instead of just one of the angles. So let's list first what we're looking for. So in this problem, we're looking for, I'm going to find two sides and one angle. All right. Let's start with the angle, theta. We know these two, 20 and 90. We just don't know the third. But we do know that 20 degrees plus 90 degrees plus theta has a sum of 180 degrees. And we know that because any triangle has a triangle angle sum of 180 degrees. So if I know two of the angles in a triangle, I can automatically find the third by using subtraction. So these two added together are going to be 110 plus theta equals 180, and this piece has to be 70 because 70 plus 110 is 180. So theta is going to be equal to 70 degrees. If you want to write that in there, you can. And right now, I can cross that off my list. I am done finding the one angle. Now I have to find the two sides. The problem is, one of the issues is I can't use Pythagorean theorem here because I only have one side length available to me. And you recall that Pythagorean theorem has three side lengths in the equation, which means you need to have two of these side lengths in order to solve for the third. I only have one, not two. So you can't use Pythagorean theorem here. So we are forced to use trig. Choose whatever angle you want to here. It does not matter. So I'll choose 20 degrees, for example. I'm going to label all the side lengths based on 20 degrees. So 20 degrees, that means 31 is going to be opposite. Y is going to be adjacent, and X is going to be hypotenuse. So, pick one side length at a time you want to find. Let's start with, let's say, X. Alright. If I want to find X, I know the opposite is 31. X is hypotenuse. That means I'm going to use sine here, opposite hypotenuse. So sine of 20 degrees is equal to 31 over X. And to solve this, you're going to cross multiply. You're going to get X times sine of 20 degrees equals 31 times 1 is 31. To solve for X still, you're going to get rid of sine 20. So the inverse of multiplication is division. And while these cancel out over here, 31 divided by sine of 20 is going to be 90.64. So X is approximately 90.64. So we found one of the two side lengths, X. Now we need to find Y. So cover up that X, and now you're looking at the diagram where you have opposite and adjacent, and that's tangent. So it's going to be, now for the second trig equation, it's going to be tangent of 20 degrees is equal to 31 over y. Do the exact same solving method, cross multiply. 31 equals y times tangent of 20 degrees. And undo multiplication, you're going to divide. Tangent of 20 degrees on both sides. And these cancel out to 1. And when you do it over here, you can get y is approximately 31 divided by tangent of 20, 85.1.